All right, everybody, we're on 10.1, Trig Ratios. This unit is all about trigonometry. And trigonometry comes from Greek words, trigon, meaning triangle, and metry means measure. Right? So we're just measuring parts of triangles, whether they be angles or sides. All right, and we have some vocab that we need to talk about first. So a trigonometric ratio is a ratio of the sides of a triangle, of right triangles. So for example, we could put a ratio of this side versus this side, okay? And the cool thing about trig is that there is a relationship between two sides of a triangle and an angle, one of these angles like over here. And we'll talk more about that as we go along. All right, so first off, or now we have like reference angle. So the reference angle is typically given, and we use the letter theta, right, to represent our angle. We'll see some others examples where they will have it just basically based off of the angle. So we could also say angle A could be our reference angle. But here we'll just do theta for now. Right? We have the hypotenuse, we have opposite side and adjacent side. So we need to be able to label what those are. So the hypotenuse is always the longest side. It's the side that is opposite of the right angle. So over here, this would be your hypotenuse. All right? Oftentimes I will abbreviate that as just H. We have the opposite side, so that is opposite of the reference angle. So here's our reference angle, and opposite of that angle is our opposite side. Okay, and then last but not least is the adjacent side. So the adjacent side is next to, thus the word adjacent, to that reference angle. So this would be adjacent. Okay, and with the opposite, I'll often call it O, and adjacent, I'll often write that as A. All right, so this is something you need to be aware of and being able to label these sides based off of a reference angle. So let's do a couple examples of that right now. Given that the reference angle theta, label the three sides of the triangle as opposite, adjacent, or hypotenuse. And again, you can just do O, A, and H. All right, so why don't you pause and give a try for these three. So here is our reference angle. Opposite of that angle's there. Our hypotenuse is always opposite of our 90-degree angle, our right angle. So this would be our hypotenuse, and then this would be our adjacent. Sometimes I like to do the hypotenuse first, so that there's no confusion on which side is the adjacent side. So hypotenuse is always opposite of those 90 degrees. We have our adjacent, which is adjacent to that reference angle. And then we have our opposites, opposite of those angles. Okay? So be good with that. Now let's talk about how reference angles affect which sides are which. So looking at these, we could either have our reference angle as A, or we could have our reference angle as B. We'll never have our reference angle as our 90 degree, okay? So let's look at the first one. So reference angle A. See if you can label these down for both angle A and angle B. Again, for naming the sides, sometimes we label the sides as the lowercase a letter that's opposite of that angle. Okay, So here we have our hypotenuse of C. That is opposite of our 90 degree. And the hypotenuse is always opposite of that 90 degree. So we could do the same for angle B. But we'll save that for a minute, okay? And then we have opposite. That's our A. And adjacent, what's adjacent to that A angle is B. All right? But now let's see what happens if we use the B angle as our reference angle. All right? So again, we still have that hypotenuse is across from that right angle. Now we have our opposite side is B, and our adjacent side is A. So you notice that the reference angle depends, or which angle depends on which side is the opposite and which is the adjacent. Okay, so just keep that in mind as you go along. All right, so here's the relationship between the reference angle and the ratios formed by two sides of a right triangle. All right, so we use these three functions, these trig functions. We have sine, cosine, and tangent. Okay, sine, cosine, and tangent. Okay, I do not like it when people say sin, cos, and tan. So anyways, just keep that in mind. So sine of theta. All right, so there is a relationship. If we know what our reference angle, there is a relationship between that reference angle and the opposite side and the hypotenuse. Okay, there is a relationship between a reference angle and the adjacent and its hypotenuse. And there is also a relationship between an angle and its opposite side and its adjacent side. Okay? So oftentimes we will have this written as SOHCAHTOA. SOHCAHTOA. And that's a good way to remember which sides correspond to sine and which sides correspond to cosine and which sides correspond to tangent. All right, so if you know this ratio, the opposite over hypotenuse, if you know what that ratio is, then there is an exact answer for what that angle would be, that reference angle, okay? And we'll get more into that, but today we'll just be focusing on identifying these ratios based off of which function, sine, cosine, or tangent. All right? All right, so here again is SOHCAHTOA. You probably want to memorize that. Again, it's a great way to remember all of these trig functions. All right, so we have a couple problems we need to do together. Again, feel free to pause when you need to. Try some of the problems, skip my work, and just go to the answers and see how you did, okay? You don't need to watch this whole thing. Just make sure you understand it as you go along. All right, so here we have, they want us to find the the trig ratio. It says reduce fractions as possible. All right, so here we want to find the trig ratio for tangent. Again, we know it's SOHCAHTOA, so T-O-A, opposite over adjacent. So we need to figure out which of these sides are opposite and adjacent. So here is our reference angle. We need to find its opposite. So opposite, or maybe we'll just call it O. And then we need to find its adjacent. So here's our adjacent. Again, I think it's a great idea for any time you have a right triangle and you know which reference angle we're going to talk about is to label all of the sides. So I think that's probably the first step that you should always do is label those sides. All right, and then we need to write down our ratio, so that would be opposite over adjacent, so that's 12 over 16. And then it says reduce your fractions if possible. So here we can simplify that. Looks like we could divide top and bottom by 4, so that would give us 3/4. Okay, so that would be our trig ratio for the tangent of theta for this example. All right, let's look at B. Sorry. All right. Now they want us to find the cosine, the ratio for cosine of Z. This is another example where in some cases we have like a theta written there. Here they're just saying that we're using angle Z. So this is our reference angle, angle Z. All right, so again, we want to write down our sides, whether they be hypotenuse, opposite, or adjacent. Okay, again, hypotenuse is opposite that right angle. It's our longest side. The opposite side is opposite of the reference angle, and the adjacent side is adjacent to that angle. All right, cosine is so so A over H. That would give us 21 over 35. All right, and that can't be reduced, so we're just done. All right, here's another example for sine. Again, I'll label the sides. Here we have our hypotenuse. Here we have, angle A. I should write that down. So this is basically our angle A, or theta, if you want to call it theta. Okay, so this would be our opposite, and this would be our adjacent. Sine is so sine is equal to opposite over hypotenuse. So opposite is 9 over hypotenuse, which is 41. And that as well cannot be reduced. Okay, so why don't you give pause for a moment, see if you can do the next 3. All right, so again, this would be our hypotenuse, opposite, and adjacent. Sine is opposite over hypotenuse, so that's 15 over 25, or reduce it to give us 3/5. We could divide top and bottom by 5. All right, cosine, so again, this is our reference angle for x, angle x, so this would be opposite, adjacent, hypotenuse. All right, so cosine is so toa, so A over H, adjacent over hypotenuse. So adjacent is 10 over 26. And that can be reduced to give us 5/13. All right, so no decimals when we're doing our ratios. We'll get into some other problems in the future where it's okay to write decimals. But when we talk about just writing down some ratios, we want to keep those exact. All right, tangent. Okay, so here's our reference angle. Here's our hypotenuse, our opposite, and our adjacent. Tangent is toa, so opposite over adjacent, oa. So that's 4 over 4 square roots of 10. All right. Sorry, I did that wrong. It is 4 over 12. All right, so that gives us 1/3. All right, I was trying to get ahead of what we're covering in a little bit. All right, so hopefully you feel good with that. It's pretty quick. Label the sides. Make sure you're using katoa, so you make sure you don't mix things up or anything, okay? All right, one thing that's kind of interesting about sine and cosine is that the hypotenuse is always greater than the opposite for like so, and the hypotenuse is always greater than the adjacent. So sine and cosine, those ratios will always be less than 1. Tangent could be different because you can see why. Like, for example, here, say we had this be your reference angle, you'd do something like 12/4, and that could be more than 1. Okay? But just kind of interesting about sine and cosine, they're always less than 1. All right. Let's talk about these. These are going to be a little different. So hopefully, at least skim through the homework, even if you feel like you're confident. There's always maybe something different that you want to make sure you don't miss. Okay? So here we're going to start the same way. All right? We have our reference angle. We have our hypotenuse, which is opposite of our right angle. We have our opposite side, opposite of the angle, and an adjacent, which is adjacent to the angle. And now we're doing sine, so that's so. And that would give us what? So 8 square roots of 3 over 16. And we could simplify our 8 over 16. That would give us like 1/2, or just square root of 3 over 2. All right? So we will have some irrational numbers, like square roots that can't be reduced to like an integer or a whole number. If that's the case, we need to make sure we simplify it as far as we can. So like that 8 over 16, that can be reduced, right? We can never divide, we could never do, like if we had the square root of 3 divided by 3, that can't be reduced, okay? It's almost like they're not like terms. Like we talked about like combining like terms. Like the square root of 3 is irrational. Dividing it by a rational, they're not like terms. You could like get a decimal, it would keep going forever, and we could need to round, and it wouldn't be precise. But this is why we don't write down our decimals sometimes, because we want to have it be precise. All right, so let's look at tangent of theta, and this one's going to be an important one because we're going to talk about something below. All right, so here we have our opposite, adjacent, and our hypotenuse. Tangent is opposite over adjacent, so TOA, sorry. Okay, and we do opposite, which is 5 over a adjacent, which is 4 square roots of 6. All right, well, you may look at this and say, ooh, that looks nice. I can't simplify my 5/4. Mr. Warner said that you can't, like, divide, 5 divided by the square root of 6. All right, doesn't go in evenly or anything like that. But there's one thing we need to talk about is something called rationalizing the denominator. So if there is a root in your denominator, we need to take care of that. We need to bring that up to the top. And how we do that is we will multiply top and bottom by the square root of 6. So multiply straight across like you normally do with multiplication of fractions. So that would give us 5 square roots of 6. And on the bottom we would get 4 and times the square root of 6 times the square root of 6. Well, the square root of 6 times the square root of 6 is the same as the square root of 6 squared. And we know that square roots and squares, those are like the opposites. They're inverses. So they cancel out, and that leaves us with a 6. And then we'd want to simplify from there. So here we'd have 24. Okay? So we need always, if we have a root in the bottom, we need to rationalize it. Okay? And here we can answer or put this in if we want. Okay? So if there is a square root in the bottom of your fraction, you need to rationalize the denominator by multiplying top and bottom by the root. Actually, I learned a new word. I don't think I ever learned it before. It's called surds. So a root that can't be reduced into it's like this would not be a surd. Okay, this would be a surd, square root of a number that can't be reduced. So like an example, if we had 1 over the square root of 2, we want to rationalize that by multiplying it by square root of 2. So square rooting or multiplying it by square root of 2 over square root of 2, that doesn't change anything. That's just 1. And that would end up giving us the square root of 2 over, again, that's the square root of 2 squared, which is just 2. So those are equal, identical, just one is being rationalized. All right. So here's one more rationalization type of problem if you want to go over this or pause and give it a try. So we want to do, this is our hypotenuse, this is our opposite and our adjacent. Cosine is adjacent over hypotenuse, so ca. All right, that would be 6 over 6 square roots of 10. All right, so again, we can reduce our numbers that are outside of our roots. So 6 over 6, well, that just gives you 1 over the square root of 10. And then we need to rationalize it by multiplying top and bottom by the square root of 10. Well, that's the square root of 10 over 10. Okay, so again, that's the square root of 10 squared, which is 10. All right, so that is it. If you have any questions, please talk to me or your teacher, if you're not my teacher. And sounds good. We'll see you guys.